everybody, so this is our last lesson for our probability unit, and we're going to be determining if two events are independent. Now we did do something like this in the past, but today we are going to elaborate on it. Before we do that, let's look at the do now. It says the graph of the equations y equals x squared plus 4x minus 1 and y plus 3 equals x are drawn on the same axis. One solution of this system is. Now there are a couple of ways you could do this problem. The best way I like to do it is to type it in the calculator and use the intersect button. Okay, so for that I'm going to open up the calculator. While it's opening up, I'm just going to rewrite our two equations. The first one is y equals x squared plus 4x minus 1. The second one was y plus 3 equals x. Now there's a problem with this second one. You would not be able to type this in the calculator because it's not in y equals form. So what we have to do is subtract 3 on both sides in order to get y by itself. And we get y equals x minus 3. So this we type into our calculator and this we type into our calculator. So we go to y equals, clear anything out that's there. Our first one was x squared plus 4x minus 1. So we have x squared plus 4x minus 1. And the second one was x minus 3. So we type that in, x minus 3. And then we go to graph. Now the solutions are where they intersect each other. If we notice here, they intersect at 2 points. This one right over there and that one. It's a little bit hard to see because they're really close to each other, but we're going to use the intersect button. So second trace intersect is 5. So scroll down to 5 and you press enter. Now it's going to say first curve. What you do is you scroll over to the first intersection, press enter 3 times. So that was 1, this is 2, this is 3. So the first intersection was -1, -4. So -1, -4. Now we can find the other one, but we don't need to. That answer choice is right here. -1, -4. Okay, so moving on. Let's do a little review of everything we've done so far. How do we know two events are independent? So two events are independent when, so they're independent when the probability of A and B is equal to the probability of A times the probability of B. So also in kind of real world terms, two events are independent when one event does not affect the other one. How do we know when two events are mutually exclusive? Remember, mutually exclusive means they cannot happen. So they cannot happen at the same time. So the probability of A and B would equal 0 because it can't happen at all at the same time, like winning and losing a race. When given a probability that says the probability of blank and blank, what do we do? So whenever we see and, that usually tells us to use this rule here. So the probability of A and B equals the probability of A times the probability of B. When given a problem says the probability of blank or blank, what do we use? Or is the key word for the addition equation. So the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. All right, and lastly, what is the formula for conditional probability and what is the key word for it? So first things first, I'm going to look at the key word. The key word for conditional probability is given or anything like it, okay? It's when you have a condition on something. Now the term for it, we'll say the probability of B given, that's what that straight line means, A, is equal to the probability of A and B divided by, just going to send the page, the probability of A. So notice the given here was A, and that goes in the denominator. It is always going to be that case. Okay, moving right along. Let's review some notation. So here's a little word bank. It would be so fun if we were in class and you guys can come up and move it, but I'll move it for us. So first things first is this upside down U. That upside down U represents the intersect. And we have that when we have the probability of A and B. The way I remember it is it looks like the N. So and. Looks like the N in and. That's how I remember that one. Okay, so then the U represents the union. That's how we say it mathematically, and is the probability of A or B. Some formulas, which I did write in the beginning, is the one for conditional probability and the one for or. Okay, the two tests for independence. The first one we've seen already. If two events are independent, the probability of A and B is equal to the probability of A times the probability of B. Now we have seen this before, but just to kind of refresh our minds, let's do an example. If probability of A is 0.2, probability of B is 0.1, and the probability of A and B is 0.3, are A and B independent? So let's look. So I'm going to write what we have. Probability of A is 0.2. The probability of B is 0.1. Now let's find the probability of A times the probability of B, which is 0.2 times 0.1. Use your calculator if you're not comfortable with that multiplication. So 0.2 times 0.1, we get 0.02. So the probability of A times the probability of B is equal to 0.02, whereas the probability of A and B was equal to 0.3. If we compare this and this, we could see that they're not equal to each other. So 0.02 is not equal to 0.3, and therefore A and B are not independent. Okay? Because the probability of A times B and the probability of A and B are not equal. So that was the first test that we've done before. This second test we haven't done before, and it has to do with conditional probability. So two events, A and B, are independent if the probability of A given B is equal to the probability of A. Or just a different notation, we're used to seeing B given A is equal to the probability of B. Notice it's equal to the first number that's there. Not number, letter. Sorry. So let's look at this example. It says if the probability of A is 0.4 and the probability of A given B is 0.4, are they independent? Well, let's see. So in this question, we are using the first one. So we need the probability of A given B. and we need to find the probability of A. So A is the first letter there, which is why we're finding the probability of A, to see if they're independent. So the probability of A given B was 0.4. The probability of A was 0.4. Now, if we were to compare these two, 0.4 is clearly equal to 0.4. So therefore, A and B are independent. Okay, so we are going to see this in a table, and we're going to use both types of tests. Okay, so both independence tests for the same problem. So this says, use the data below to show whether or not passing a test and gender are independent or dependent. Now, notice here we have passed, failed, male, female. They didn't really tell us which to use. They didn't tell us to use passed or failed or male or female, so we can choose, okay? So we're going to choose two events, A and B. So why don't we choose event A to be passed and event B to be male? Again, it doesn't matter which you choose. The question did not specify. So we are going to be using the independence test. So we're going to need to find the probability of A. We're going to need to find the probability of B. And then we'll get to the rest. Let's start there. So the probability of A, the probability that you passed the test. So we look at the total. So 135 people passed the test out of 210 total. Now notice I used the absolute total because we're not using a given probability here or a conditional probability. We want to look at everyone who took this test. So now let's look at the probability of B, which is the probability of male. Why don't I use a different color for this? Oh no. Okay, why don't I use a different color for this so I can color code? So the probability of B, which is the probability of the male. So here we look at male. The total number of males is 84 out of the total number of people, which is 210. Okay, so that was the first part. Find the probability of A, find the probability of B. Now we have to find the probability of A. That's not very good color coding. Okay, so now we have to find the probability of A times the probability of B, which is, the probability of A is 135 over 210 times the probability of B, which is 84 over 210. Let's multiply these with our calculator. So to get a fraction, alpha y equals, we have 135 over 210 times, again, alpha y equals 84 over 210. Press enter and we get 9 over 35. So this is 9 over 35. Now let's use our table to find the probability of A and B. So this means the probability that we have someone who passed and they're a male. So if we look at passed and we look at male, they intersect at this 54. So that means 54 out of the absolute total of 210 passed and they were male. Now, we have to compare these two numbers. When I see fractions like that, I cannot compare 9 over 35 to 54 over 210. It's hard. It's a lot easier to compare decimals, so I'm going to change them to decimals. So we have 54 over 2, whoa, that's not what I wanted. 54 over 210, and that gives us that long thing. So I'm just going to round it to this 7, okay? So 0.257. So So this is 0.257. And let's see what this first one is as a decimal. 9 over 35. So that's not what I wanted. 9 divided by, that's not a 9. Oh my gosh, sorry guys. So 9 divided by 35, and we get 0.257. Okay, I fit it there. Now we compare these two. So 0.257 is equal to 0.257. They're the same decimal. So that means they are independent events. So independent events. Okay, you can explain why, but I'm just going to write that for this one. Now we're going to use the second independence test with the same data information. We're just going to use the conditional probability one. So again, it says use the data below to show whether or not passing a test and gender are independent or dependent events. So for the conditional probability test, we still need to identify A and B. So let's identify A and B. I'll color code. Okay, so again, they don't specify whether we're looking at passing or failing or male or female, so we can pick. So last time we did passed and male. This time, why don't we use failed and female? So A will be failed and B will be female. Okay, so now what we need to find is we need to find the probability. Use a different color. We need to find the probability of female given that they fit. That's not supposed to be a B. The probability of female given that they failed. Okay, so failed is our given. That means we circle this. We know they had to fail a test. Don't care about past, don't care about the total. Only care about what's circled here. Now, this letter, the B, represented females, so we circle the female number. And to find the probability, this becomes 45 over our total of 75. Now remember before is when we compare fractions, it gets a little difficult. So I always suggest turning it into a decimal. So why don't we do that from now? So 45 divided by 75. And we get 0.06. 0.6. Now what we can do is we can see if this is equal to the probability of just B, because that's what's going to tell us if we have independent or dependent events. So I'm going to erase this from here so I can find the probability that we have a female. Now, we're not limiting our sample space here. We don't have a given, so we look at the absolute total. So this is going to be over 210. And now we care about the number of females, and the female total is here, 126. So let's see what this looks like as a decimal. 126 divided by 210. And we get 0.6. Now looking at this, 0.6 equals 0.6, right? That tells us we have independent events. Again, you can write an explanation if you'd like, but I'm going to leave it there. So you can use either test if they don't specify a given. So if they're not telling you the word given in your problem, like they didn't tell us before, you can use either one. But if they say given, once that word shows up or something like it, you have to use the conditional probability test. So let's do another example. So the results of a poll of 200 students are shown below. For this group, do these data points suggest that gender and preferred music style are independent of each other? So notice they didn't specify a specific gender or a specific music style. They also didn't tell us which independence test to use because it doesn't say the word given. Now, I want to use the conditional probability one just because we've seen that one less. So the probability of B given A is equal to the probability of B if they're independent events. Okay? Now, we have to identify an A and B. Remember, they don't specify it here, so we could choose whatever we want for A and B. So, since I like country music, A is going to be country, and B is going to be female. You can use whichever one you want, though. You could use rap and female or rap and male, techno female, it doesn't matter because it didn't specify. So now, first thing we need to find is the probability of B given A. So A is our given, that means country is our given, so I'm going to circle this. We don't care about rap or techno right now. So the total number of country, we don't know that. So what we have to do is we have to add 27 plus 18. 27 plus 18 gives us 45. So that tells us 45 people out of the 200 chose country as their preferred music style, and we only are looking at the females, so I'm going to circle the number that represents the females, which is 27. When comparing, fractions are really hard, so we change it to a decimal. So we do 27 divided by 45. 27 divided by 45, and we get 0.6. Now, let's find the probability of B and compare them. So the probability of B is the probability that the person being polled was a female. So now we look at the absolute total. We're not reducing our sample space. Two ways you can get it. You can either add up all these numbers or look, it tells us how many students were polled. So we know that 200 people took this survey. Now we have to figure out how many of them are female. To figure that out, we have to add up the female column. So 54 plus 25 plus 27. 54 plus 25 plus 27, that is 106. So this tells us that 106 out of the 200 people surveyed were female. Let's figure out what this number is. So 106 divided by 200, we get 0.53. Now we compare these two numbers here. 0.6 is not equal to 0.53. I don't care if they're close, they're not the same. Since they are not equal, that tells us that they are not independent. So gender and preferred music style are not independent. Okay? Now to get credit for this class, complete this check for understanding on a separate sheet of paper and upload a picture of your work and solution to the Google Classroom. Have a great day, guys.